it gets too hot in here as well. Although you probably don't feel like that since you all have your coats on. Yeah, hot. Yeah.
No.
That's what I said, yeah.
That's DAV009 is called that.
Yeah, it's nice, isn't it? It's nice, yeah. Not cold is good. Nice and fresh.
Nah.
Wake you up.
Not too much.
Okay, so if you can write that down, resolving vectors is what we're looking at. Not too difficult, actually quite a short lesson. The next lesson will be a little bit harder since we'll move away from vectors. So resolving vectors. Can you see okay there? Yeah. Alright, so let's start then this one here. Okay, so horizontal means this, and vertical means this. Horizontal, vertical. If you didn't know that, you should write those words down. So, horizontal and vertical vectors can be added together, just like any normal vector. And actually, this is a pretty common problem in mechanics. But what also is an important problem is the opposite. What I mean by that is you take a vector and you write it as a sum of the horizontal and the vertical. So what I mean here, we can have a horizontal, we can add it to a vertical, and we can make the vector. What we want to learn today is to take the vector and write it back as the horizontal plus the vertical. This is resolving vectors. Okay. Right, so you don't need to write all this down. The key words I care about here are in red, horizontal and vertical. Do you understand the meaning of resolve? Yeah? Is it okay? Let's have a look. Let's continue then. It's good to see you writing, but there's lots to do. You don't need to write everything here. This is just a lead-in. Okay, so this theorem you all know from middle school, I hope. Pythagoras, or what's it in Chinese? Something like go-go-D or something. What's this? You know this.
You mean that A squared?
Yeah, what's this? Who's the name of the person? What's this called in Chinese?
Go.
As close. So, you all know this theorem, Pythagoras theorem, and actually this will be useful for today's lesson. I'm sure you know it. If you don't, that's fine, just write it down. But what you should all write down, especially the Chinese students, is the name of this, Pythagoras. I'm sure in, who's my Malaysian students? There. Is it Pythagoras, still Pythagoras back home? Yeah. And Korean students? Oh, not the same then, okay. Korean students, you still say Pythagoras, yeah? And obviously for you, still Pythagoras then, okay. So people who have Pythagoras known by a different name, can you write his name down, please? It's a word we use a lot. Yeah. Were you checking your dictionary?
Yeah, I just
Check what?
Okay, that's why.
Pythagoras? Oh, yeah, okay. Alright, let's continue then. So Pythagoras just said, if you have a right angle triangle, then a squared equals b squared plus c squared. But you all know this from middle school. And it's useful for this lesson for vectors. Okay, so here's a very simple example to get started. I tell you there's a magnitude, a vector, which is 3 meters east and 4 meters north. You add them together, you get the result, and I want the magnitude of the result. And I'm sure some people already know the answer from looking at this. Can anyone tell me the answer here? You have 3 meters here, 4 meters here, 5 meters here, from Pythagoras. Yeah, so this is just a small example to warm up. Let's go on to something else then. Vocabulary now. So when we're talking about a vector with this angle, this direction here, can you see theta? These sides have names. This is called the opposite. Why? Well, because it's opposite the theta here. This side is called adjacent. Adjacent is a synonym for neighbour. So adjacent means neighbour. And hypotenuse, I don't know why it's called hypotenuse, it's just called hypotenuse. Okay, so the longest side is the hypotenuse. Everybody should write these words down, because we'll need these words. Did you study through English or Korean? Yeah. Yeah. Oh, good, okay. So all these words are familiar?
Not really, I didn't use that.
Oh, these didn't come up in physics?
Yeah. Actually, the sine, cosine.
Yeah. Sine, cosine, tan, yeah. Okay, do you have those words? Yeah, just write them down. Some people might recognize the name of this slide. Have a look at the name of the slide at the top.
So
You know this word? Mm-hmm. Anyone else know this word? You know this word? It'll become clear in maths class maybe, or maybe later today. Okay, can I continue? Yep. So we have a way of finding this angle here if we know the opposite and the adjacent. And in physics, that's usually what we are dealing with. So if we know the opposite and the adjacent, then we can use this on our calculator to find the angle. In fact, there's three of them which you know: sine, cos, and tan. Does anyone remember what sine equals? Over hypotenuse. Sine is opposite over hypotenuse. Yeah? Cosine? Adjacent over hypotenuse. And tangent? Opposite over adjacent. SOHCAHTOA. Yeah? This is a new word? Yeah, I think maybe new word for some people here. Anyways, the one that we care about is the TOA. Finding the angle here, we use this. Does anyone know what this is called? I think I said it already, but there's tan inverse. But there is another name for it, especially the American educated students. Who are those? The Americans don't say tan inverse. Or maybe some do. Arctan. You heard this one? Yeah, arctan. Yeah. Okay, let's continue then. Okay, so now back to the question we had a moment ago. What is the direction if we had 3 meters east and 4 meters north? So I didn't open my calculator, so I'll need someone to use their calculator here. Okay, so here's our vector, and it was because we added this, which is 3 meters long, and this, which is 4 meters in magnitude, and we said that this is 5 meters. So if I call this vector or, then the magnitude of or is equal to 5 meters. Okay, and the direction, the theta, will be tan inverse 4 over 3. Now I don't have my calculator, so maybe somebody with a calculator. Yeah, 53.13 then, okay. So this is the direction, and this here we got from Pythagoras is the magnitude. Okay, can you write this example down and then we'll continue? Let me open up my calculator because I'll need it later anyways.
This is lots of this
Say again?
this lots of this.
Oh yeah, how to say it, yeah. North of east is good, correct, yeah. Okay. Continue or? Okay, continue. Yep. Bruce? Okay. Yeah? Okay. Let's continue. Okay, so I was saying this earlier. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. I think everybody knows this from high school, middle school. And this is the word which we use to describe this, to remember this. Often we know the magnitude of the hypotenuse and the angle. These are usually the things we know. So we would like to know what is the opposite and the adjacent. So we can use sine cos tan, and let me show you how. So let's see how. Okay. Right, so here's our vector. And we know the magnitude, so we'll say that it's or magnitude. Actually, to make it clearer, I'll put the things we know in blue. So we know the magnitude, and we know the direction here. And what we would like is this one is magnitude, and this one here. So we'll call this x, and we'll call this y. So let's start with the x. And we know the or. So if we're looking at the adjacent and the hypotenuse, we should use cos. So we have cos theta equals x over or. So that means x is or magnitude multiply cos theta. And likewise we can say sine theta equals y over or. So that means y equals or sine theta. What I expect from students is that they should do this automatically. So for example, if there was a question like this, where this is theta and this is or, then you automatically write down that this side is or cos theta and this side is or sine theta. Without going through this process. In the exam this is fine. So how do we remember which side is the cos and which side is the sine? Well, the key here is the cos is always the side that touches the angle. And this is a useful trick because sometimes these problems can get a bit difficult. You can have, things like this. And maybe I'll call this here alpha. And this can be, I don't know, p or something. So you're saying, which one is the cos and which one's the sine? And, it can get a bit confusing. But if you just remember, cos is the one that touches the angle, then this side here is the cos, and this side here is the sine. So it's a useful trick that you really should use in the exam because it wastes time to draw this triangle and to figure out which is which. So just automatically write down this one's the cos and this side is the sine. Okay. So can you make note of this, in particular this shortcut trick here, that the cos goes with the theta. Okay, so write this down please and then we'll continue. Yeah?
Which is German like that. Does it teach only apply to right angles?
Yeah, only for right angle. This is a right angle triangle if I draw this side up here to make the triangle. Yeah. Okay, you got that? Bruce?
Yeah.
You got it?
Mm-hmm.
Are you sure?
Yeah.
Okay. Let's continue then. So, speed we were talking about the last time, and as a formal definition, speed is the magnitude of the velocity vector. That's the mathematical definition using vectors. So if you can write this definition down, speed is the magnitude of velocity. Okay. Got that? Yeah. Let's continue then. Yeah, you have that, Bruce? Yeah. So we have a vector, here's another example. We have a vector which is 10 meters per second horizontally and 20 meters per second vertically. So it's 10 this way and 20 this way. And I would like the magnitude and direction. I'll give you 30 seconds to do this. It's not too difficult. So give me the magnitude using Pythagoras and the direction using tan inverse. Yep. You got your calculator, Bruce?
Yeah.
Okay, good. Okay, do we have the magnitude?
Yeah.
What you get?
200.3.
Okay, let's have a calculation here. So Pythagoras says the magnitude here, using his theorem, would be 10 squared plus 20 squared. And that is... I think you forgot the square root, maybe?
Oh, yeah.
Yeah. 22.36 meters per second. Some people can, yeah?
Actually, can I write just 10 minutes time?
You can, but actually, in the exam, they prefer you to write this.
They prefer.
Yes, I know. I know. Don't think about it too hard. It's a bit strange. But in the exam, all the answers, they usually want it like this. Yeah. Okay. And did somebody get the angle? Tan inverse 63, is it? Okay, let's double check. Very good, 63.4 degrees north of east. Okay, can we continue? Right. Load in. Okay, now this is an example where we have to do it the opposite way. We have a ship heading 15 kilometers an hour, bearing 30 degrees. How fast is it traveling east and north? Let's see how you do with this one. I'll let you try it. So this is where you have to use the cos and the sine. Okay, you have an answer? Yeah. Let's see people working. You have an answer over there, yeah? Yeah. Okay, let's have a look. So what's the magnitude here for this vector? Let me just draw in my compass. East, west, north, south. What's the magnitude here? Yeah, 15, is it? Great. So that's the 15. And this is 30. Yes, I tricked you. Because I said bearing of 30. So this vector here is 15 cos 30, and this vector here, which is the same as this one, is 15 sine 30. So 15 cos and 15 sine. What is that? Let's have a look. 15 sine 30. So east is this. 7.5. East. And north is, you have it there? 13 about, yeah. 12.99. So 13 kilometers per hour north, and 7.5 kilometers per hour east then. Did most people fall for my trick? Did most people put the 30 down here? Yeah.
What is the meaning of that?
Bearing means from the north. Yeah, from the north. Okay. Did I manage to trick everybody with that? Yes? Huh? No, not everybody? Okay. Right, so I have some questions here, and again, well, I don't know if we get them finished now today, because a couple of them get a bit hard towards the end. I'd say you'd be okay. Yeah, you should be okay, except you might have a little bit of trouble with the last one. So we can try these for a few minutes and then we'll start the next lesson. Yeah, you know what? You might have no homework if you get these done now. We'll just do these for a few minutes. Go.